polar representation of a complex number. Okay, so we have discussed few things earlier also, that every complex number can be represented as a point xy. Like if a complex number z is equal to x plus iota y, then it can be represented as point xy. Okay, and say this is plotted as, this is x, take this distance as y, and this r which is equal to mod of z, and z is equal to x plus iota y. This type of representation is called rectangular form, and z is equal to r times cos theta plus iota sin theta. This is called your polar form. Okay, so point P, so this is point P, is uniquely determined by ordered pairs, which are your real number. Okay, these ordered pairs are real numbers, which are your r and theta. Okay, called polar coordinates of point P. Okay, polar coordinates. Like if we compare from here, x is your r cos theta and y is your r sin theta. Okay, and that's why this form is framed like you can see from here. When replacing x and y by r cos theta and y sin theta, we call it as the polar form of complex number. Okay, now here this r is your modulus. Okay, modulus of a complex number, and if z is equal to x plus iota y, we take modulus as using the Pythagoras theorem as under root of real part square plus imaginary part square. Okay, and this theta, main thing is this theta, this is called as argument of z. Okay, this is called as argument, or we call it as amplitude also, amplitude of z. Okay, which is denoted by, write it as say argument of z. We don't write as say amplitude. Okay, now yesterday I gave you in the lesson that it can be written as say is in first quadrant, if the point is there, it is theta, then second it is pi minus theta. So let us understand why it is behaving like this. Okay, so you will find that when we take this arguments, that when we are dealing with arguments, you note down few things, that for any complex number z not equal to 0, okay, z not equal to 0, there is only one value, of theta in your greater than equal to 0 and less than 2 pi. Okay, now for example, this your value which is lying between minus pi to pi. Okay, this value which can be your, means this is one of the value interval lying between this. Okay, so we need to, you will find so many values as it will be repeating. We need to take the values of theta, right, in such a manner that it is lying between minus pi to pi. Okay, it is lying between minus pi and pi. Here we take the equal to sign, and this is called as the principal argument of z. Okay, this is called as the principal argument of z. Now yesterday we framed a table. What was it that we were discussing? That in first quadrant we take the value as, okay, I am taking all the points, all examples in which say you are taking a complex number. In say we will take 4 examples. Okay, so first of all let us go for this. Say this is the first quadrant, the point, this is the case of second. The point is here. Okay, this your point xy is there. So this will be your mod z, this is your OAB. Okay, and this is your theta with the positive direction of x-axis. This angle I told you with the positive direction of x-axis. This is your theta. So in first quadrant with positive direction of x-axis, In first quadrant, this argument of z is theta itself. Okay, that's why I told you it is theta itself. Now what happens if the point is in second quadrant? See, the point is here. Say this is A, this is O, and say this is B. Now in this case, this is point XY. Okay, now you know that the point, say angle here is your theta. Okay, you call it as that the angle which we are taking inside here is theta. But you know if I have to frame an angle which is with the positive direction of this x-axis, which this ray or line is making. So can you tell me what will be this angle? Don't you think it is 180 minus theta or pi minus theta? Because you know we are talking about the angle which the line makes with the positive direction of x-axis, this line. Okay, so that's why the argument z is taken as 180 minus theta or pi minus theta when a complex number is having your x negative and y positive, means it is lying in the second quadrant. Now let's come to your case of third quadrant and then comes to the case of your fourth quadrant. Okay, so third quadrant means I'll be here. Now situation is my z is here, this is your O, say this is A, this point is B, okay, and this is your mod of z. Okay, so now this is theta, as it is clear. Okay, this is now theta. But you know, as I'm in the downward direction, so the anti-clockwise means now 180 minus theta is this. Can you see? It is 180 minus theta, now this angle. But this angle is clockwise. That's why argument of z. You know, clockwise angles are negative. We take it as minus 180 minus theta. Okay, or we call it as minus 180 plus theta, or we can write like this also, minus 180 plus theta. Okay, and in fourth quadrant, okay, this is my third quadrant case, my fourth quadrant case, like I can have it here. So this is your mod z, this is O, this is A, the point xy. Okay, I'm not writing it as minus x minus y or x minus xy. You know, if some point is there, then which coordinate is going to be a negative or not. Okay, so like here, now the angle is directly this. Why should I go like this? It is your just, say if it is theta, as it is in again clockwise motion. So here, that's why we take argument as minus theta. Okay. So what do we understand by this? That in first quadrant, okay, in first quadrant, like xy both positive, like say the complex number 1 plus iota, okay, which will be like your 1 1, okay. In such case, the argument of z will be theta itself, theta. In second quadrant, like the quadrant minus xy, like the this your example minus 1 plus iota, okay, the point will be minus 1 1, second quadrant, and argument will be taken as pi minus theta. Okay, in third quadrant, like both are negative, like the example minus iota point minus 1, and in this case argument of z will be minus 180 minus theta. In fourth quadrant, you know, x is positive, y is negative. Like it is, say for example, 1 minus iota, like 1 minus 1. So in such case, argument of z will be your minus of theta. Okay, so if you remember this table, I think there will be no difficulty in forming the polar form. Exercise 5.2, question number 1. Now here we are just supposed to find the modulus and argument, but one step ahead is your polar form. So z is minus 1 minus iota root 3, and we'll compare it with x plus iota y. We find x as minus 1, y is minus root 3. Means the point is minus 1 minus root 3, which is lying in the third quadrant. Now start with x is equal to r cos theta and y is equal to r sin theta. Okay, squaring and adding. See, this is 1, this is 2. I'll get it as x square, okay, left to left and right to right, is equal to r square cos square theta plus sin square theta. So I'll get x square plus y square equal to r square, as cos square theta plus sin square theta is 1. So it is minus 1 square plus minus root 3 square is r square. So r square is your 1 plus 3, that is 4, implies r is plus minus 2. But r, you know, is a distance, is modulus of z, so r is your just 2. So this is your r, which is same as your modulus z. Okay, now let us now search for argument. Okay, now put it back in r, x is equal to r cos theta and y is equal to r sin theta. So x here is your minus 1 is equal to 2 cos theta and your minus root 3 is equal to 2 sin theta. So I'll get cos theta as minus half, sin theta as minus root 3 by 2. Okay, now as both x and y are negative, or you can say that both cos theta and sin theta are negative, so that means point lies in third quadrant. Okay, now here the signs are not mandatory, they just let me know that in which quadrant the point is lying. Okay, so I don't want to see for these negative numbers. Okay, I just want to know that cos theta, when is cos theta half and sin theta is root 3 by 2. There is just one common angle. Okay, so cos theta, sin theta is root 3 by 2 at 60, because at 30 it is 1 by 2, and at the 60 also it is, cos is behaving reverse, so it is 1 by 2. So you will get a common value. So here after looking for it, means here theta is your 60. 60 is pi by 3 or 60 degree. Okay, pi by 3 just can be obtained by dividing it by into multiplying it by pi upon 180. Okay, so that you will learn when we will do trigonometrical equations. Okay, so pi by 3 and or even 180 by 3 is again 60, that way also you can just locate it. Okay, so here the theta is your pi by 3 or 60 degree. Okay, but it is not the argument. Okay, since the point is lying in which quadrant? Third quadrant. Now since your xy lies in which quadrant? Third quadrant. So argument of z is your third quadrant, minus 180 minus theta. So it is minus 180 minus, you can write pi by 3, you can write 60, that is minus your 180 minus 60, that is minus 120. Okay, minus 120 can be written as radian measure if you not, means pi minus pi by 3, or you can just multiply by pi upon 180. Okay, so it is 2 6 are 12, 2 9s are 18, 3 2s are 6, 3 3s are 9, so it is minus 2 pi by 3. And even also from here if I take pi minus pi by 3, so you can take it as minus times 2 pi by 3. Okay, so what is the polar form? So polar form is your r cos theta plus iota sin theta, that is it is equal to r is your 2 cos minus 2 pi by 3 plus sine minus 2 pi by 3. So this is your polar form of this complex number. Okay, and your z is here iota, just iota. Okay, now z is equal to iota and we can write it as 0 plus iota. Okay, so if I need to compare it with x plus iota by, so I'll get x as 0 and y as your 1. Okay, and you know in polar form what is your x? It is r cos theta and y is r sin theta. So modulus, either you can directly squaring and adding get from here, or you can just start from here, as this is also one thing you must remember, squaring and adding. Okay, 1 and 2. What will I get? X square plus y square is equal to r square. I took r square common. Okay, cos square theta plus sin square theta. As I know it is r square cos square theta plus r square sin square theta, so I will take r square common. Okay, so it is your it becomes r square because this is your 1 by the identity cos square theta plus sin square theta is equal to 1. Okay, so x square plus y square equal to r square. Now x square is your 0 square, this is 1 square and r square. This thing implies r is your plus minus 1. But you know that r is always positive because it is the modulus, it is the distance. Okay, remember. So this is the distance. So it is always means I cannot take negative value. So that's why I have to ignore the negative one and r is your 1. Now come back to 1 and 2. It implies x is equal to r cos theta and y is equal to r sin theta. Okay, so this is the modulus which I got. This is your mod z or r. Okay, first thing. Now I get as x is 0 and r is your 1. So it is cos theta. And y is 1 and r is 1. So it is 1 cos theta. So I get cos theta as 0 and your sin theta as 1. Okay, so from here now it is very much clear to me that x was your 0 and y was your 1. So if I'll convert it to point, the point will be 0, 1, and this point is lying in first quadrant. Okay, and because in first quadrant both cos and sin are positive. Okay, so what will I do is now from here I am now going to decide for argument. Okay, so what is there that I should now check out. Signs are not important here. You need not see whether cos is no doubt here both are positive, but if someone is negative also, it is not your work to see here which sign they are attaining, because sign will just tell me in which quadrant they are lying, and accordingly I will choose the argument. But here check this value. When is cos 0 and sin 1? There is one common angle at which cos is 0 and sin is 1. Okay, so what is that angle? Cos theta is 0 and sin theta is 1 at theta is equal to 90 degree. You know sin 90 is 1 and cos 90 is 0 at theta equal to 90 degree. Okay, so as the point is in first quadrant, and you know what is argument set there? Argument set is theta itself. So it is just pi by 2. Okay, so this is how we frame the argument. So what is polar? Polar form is r cos theta plus iota sin theta, and your work is just to replace the value of r by 1, and it is your cos pi by 2 plus iota sin pi by 2. So this is the polar form of this complex number. Okay, square root of a complex number. This is your supplementary exercise, and you have to find like root 5 minus 12 iota. The question will be like express it in the form of a plus iota b. Okay, or simplify or evaluate root 5 minus 12 iota. Okay, so it is all about the finding the square root of a complex number. Or if z is equal to 5 minus 12 iota, means the question can be like if z is equal to say 5 minus 12 iota, find root z. So it is clear that you have to find root 5 minus 12 iota, and you have to then express it in the form of z. Okay, z is equal to a plus iota b. So that means simply means you have to find the square root of the complex number. Now how will we go? It's a very simple thing, nothing new in it. So like this is your complex number x plus iota y. Okay, and now I'm going to search the values of x and y using this. So very first thing is the concept of square root always says take the square, squaring both sides. So you get it as 5 minus 12 iota whole square will give you this, and this is x plus iota y whole square. Okay, you can write it to this side also. It is your x square plus it will be iota square y square plus 2xy iota. So it is your, if you remember, it is x square minus y square, as iota square is minus 1. Okay, and plus 2xy iota, and this is your 5 minus 12 iota. Now by the equality of complex numbers, x square minus y square equal to 5 and 2xy is equal to minus 12. Don't take it as iota because I am just comparing the parts. So 2xy is equal to minus 12. Now this is the crucial thing, and this xy is equal to 2xy is equal to minus 12, it will help me in finding out. Say, the product of x and y is resulting in negative. That means when I'll frame the complex number, I'll keep it in mind that if x is positive, then y must be negative, and if x is negative, then y must be positive, because then only the product of two numbers will be negative. Otherwise, if both x and y are negative, both x and y are positive, it will be positive, result will be positive. But as you can see, the product is negative. That means if x is negative, is positive, y is negative, x is negative, y is positive. Okay, so in this way, so that will be the different thing. So when you have to calculate the value of x and y, I already have got x square minus y square equal to 5. So I should go for now x square plus y square equal to something, so that I can evaluate x and y. Okay, so here I'll use a formula, very good formula, which x square plus y square whole square is equal to x square minus y square whole square, okay, plus 2xy whole square. Now open it, what it becomes? It is x4 plus y4 plus 2x square y square. It is your x4 plus y4 minus 2x square y square plus 4x square y square will give me the same thing, plus 2x square y square to this side also. Okay, so I think there is no problem in understanding it, that why I am using this formula. And also all these values I am having here, like x square minus y square, this is your 5 square plus minus 12 whole square. So it is your 25 plus 144, 169, and I know x square plus y square whole square is equal to 169. So that means x square plus y square is equal to 13. Okay, not minus 13. X square plus y square means taking the square. It is not equal to minus 13, because the square of two numbers can never be negative. Sum of square of two numbers can never be negative. So this is your number 2. Now I will solve x square plus y square equal to 5, 13, and x square minus y square equal to 5, which I do by adding 2x square is equal to 18, x square is equal to 9, and x is equal to plus minus 3. Now if x square is plus minus 3, so you know y square is your 13 minus x square. So it is 13 minus 9, that is 4. So y is plus minus 2. Y is plus minus 2. So coming back again, what will I do is, I know that when x is positive, y is negative, x is negative, y is positive. So while framing the complex number, what will I keep in my mind is that the complex numbers are, what will I keep in mind? That I will frame the number like x plus iota y, but when x is, I'll take as plus 3, I'll take y as minus 2. So that complex number is 3 minus 2 iota. Okay, square root of complex number, that is z is, because we took root z as this. Okay, x as root of this. So, and when x is minus 3, your y is plus 2. So in this case, the complex number is. So why I need to choose these alternate signs? Because this number 2 is the deciding factor. Okay, so I get x as minus 3 and y as plus 2. Okay, so this is simple thing. Complex number minus 7 minus 24 iota, that is I need to calculate this square root of this. Okay, so again I'm going to start with, let z is your under root of minus 7 minus 24 iota, that is x plus iota y is squaring. What will I get? X plus iota y squaring both sides. So this whole square is minus 7 minus 24 iota. So this is x square minus iota square y square. Okay, no, it is plus iota square y square plus 2x iota y is equal to minus 7 minus 24 iota. So this all together, x square minus y square plus 2xy iota is minus 7 minus 24 iota. Okay, so x square minus y square is minus 7 and 2xy is minus 24. So again, as when x both are having negative sign, so when x is positive, y negative, when x is negative, y is positive, and x is positive, y is negative. Okay, so this is your number 1, this is number 2, and now I will use the formula. X square plus y square whole square is minus y square whole square plus 2xy square. I'll take 1 and 2 into consideration. Plus minus 24 square, so this is 49 plus 576, this is 620. From here, x square plus y square equal to 25, this is number 3. Now I'll solve x square plus y square equal to 25, x square minus 7, so adding 2x square is your 18, x square 9, xs plus minus 3. Okay, and now y square is 25 minus x square, so it is 25 minus 9. Okay, so it is your 16, so y is plus minus 4. Okay, now let us come to, as this equation number 2 was giving me the alternate signs. Okay, because it was having the term as negative, so I'll frame the square root as when x is 3, y is 4, that is z is y is minus 4, so it is 3 minus 4 iota, and when x is minus 3, y is plus 4, the complex number is minus 3 plus 4 iota. So the square root of two complex numbers, they are like 3 minus 4 iota and minus 3 plus 4 iota.